Okay, everybody, so here's another installment of my mini lectures. This particular mini lecture is going to cover molecular compounds. These are going to be bonded covalently. These are not metals. We're only talking about nonmetals. We're going to talk about molecular compounds, how to name them properly, how to be able to take the name and determine the formula properly, and then we're going to talk about the anions, or the negatively charged polyatomic ions, that we also need to know the names of. These are molecular compounds. They just happen to have a charge, and I'm going to teach you a quick way and a shortcut to understand those charges. So let's take a look here. What I have written for you here is the periodic table to the right of the stair-step line. We're talking only nonmetals, right? All of these are all nonmetals. So that's important because when we're talking molecular compounds, we're only talking nonmetals. If you see a metal in the compound, meaning if you see anything that is to the left of the metalloids, then it is an ionic compound exclusively for the purposes of this class. It's always going to be ionic. If you see a metal, ionic. If you see two nonmetals, then you need to know immediately that this is what is considered a molecular compound. That means the interaction between the nonmetals are different than the metals. Nonmetals tend to share electrons, and we'll get into this when we talk about more bonding. But nonmetals tend to share electrons. So molecular compounds are made of two or more nonmetals. This should say two or more. Two or more nonmetals. And the name for any of these has to be determined by a prefix which is associated with the amount of atoms. So what I have written for you here is a table of the prefixes, what their name is, and how many atoms they are associated with. We're going to use these, but you need to know these. You will not be provided this chart. You need to know these. But you do not have a prefix for the first element in the molecular compound if there is only one atom. If there's only one atom. So here we have two examples already written. Then we're going to go through a couple more examples. So here I have written NF3. NF3. Okay. N is for nitrogen, nonmetal. F is for fluorine, nonmetal. Okay. Since we only have one nitrogen, the proper way to name this would just be to write the element's name, nitrogen. First step done. That's simple. If there's one atom, you literally take the name right off the periodic table. The second atom in a molecular compound will always have a prefix, right? Will always have a prefix. So I'm going to put a star here. Second atom will always have prefix. Regardless if it's 1, 2, 3, 4, 5, 6, so on and so forth. Always have a prefix. So, because we have 3 atoms of fluorine, then we need to look at the 3 prefix, and you see that I have written here in a different color, tri. T-R-I. So, that's the second step. First step, first element and its name. Second step, second element, prefix before you write anything about the element. And then the last thing to do is write the element's name, but you change the ending to IDE. So, second element ending is dash IDE, meaning we add IDE to the end. And this is why you see that I do not have nitrogen trifluorine. That is incorrect. It is nitrogen trifluoride, IDE. Okay? Let's look at another example, still following these same rules. We have O2Cl5. O2Cl5. The two elements involved here, oxygen, nonmetal, chlorine, nonmetal. This is a little bit different because we do have a more than one atom as our first element. So that means that we do need a prefix for our first element. So only if you have more than one do you need a prefix for the first element in the name. So now we see that we have 2. We need to go to 2 in our prefix table and put dioxygen. So dioxygen, remember, we do not add anything to the end of the name. We only add a prefix. Only add a prefix. Okay, from there we look at the next element and we look at the number of atoms. We see that we have 5 atoms. 5 is penta. And we end up with pentachloride. Pentachloride. So we see that this IDE is due to the second element always having IDE. Okay? So a quick recap before we do some other examples. First element, if there's only one of them, one atom, the name straight from the periodic table. Second element always has a prefix and always has IDE at the end. And that is the basics for molecular compounds and the nomenclature for molecular compounds. Once you got this rule set, pretty straightforward, pretty easy. So let's look at a couple different examples. Let's look at CO and let's look at SBR6. Okay, here's 2 different examples. What I would suggest is pause the video now, determine the answer yourself, test yourself really quick, and then come back and hit play and figure out if you got it correct or not. Okay, so here we go with C and O. C is a nonmetal, carbon. O is a nonmetal, oxygen. We only have one carbon. We only have one carbon. Therefore, we can write the name right out the periodic table. All right. Remember, second atom or second element, always has a prefix. We only have one here. Remember, a 1 is assumed here. We just don't write it. We have a 1 here, so we must go to the table and write mono. And remember, we changed the element name to show IDE on the end. So for oxygen, which is kind of a little bit of an exception, still has IDE on the end, but it's oxide. So it's written as such. It is not carbon monoxide, it's carbon monoxide. We don't have 2 O's side by side. So carbon monoxide, because there's only a 1 here. All right. SBR6, sulfur nonmetal, bromine nonmetal. Sulfur is only one of them, so we have sulfur right off the periodic table. And then we have 6 bromines, that is hexa. So we use our prefix hexa. And then bromide. Remember, we have to have that IDE. It's not sulfur hexabromine. If you write sulfur hexabromine, it will be partially incorrect. Now, all of these examples I've showed thus far are examples of taking the formula and figuring out the name. You also must be able to do the reverse. Okay? So let's look at some examples of doing the reverse. Okay. Here are two more examples. But now I'm giving you the name. You must be able to look at the name and determine the formula based off of the prefixes and the elements. So in this first example, we have trinitrogen disulfide. So trinitrogen, that means we have 3 nitrogens. Again, if you do not know these and you start seeing these prefixes on a quiz or assessment, then it's going to be very difficult for you to get it right. So trinitrogen disulfide means that we have N3. Sulfide is sulfur. Di is 2. N3S2. Silicon tetrafluoride. Silicon is Si. Fluoride is F. Silicon we only have one of based on the name. So we have Si. Tetrafluoride, that's 4F4. Now, for molecular compounds, that is all you need to know for nomenclature, for the development of them, writing the formula from the name, writing the name from the formula, and it's a pretty straightforward process. Just be consistent. Be consistent. All right. If there are any questions, again, feel free to shoot me an email. This is molecular compounds, nonmetals, nomenclature, what they are, how we determine them, where they should be on the periodic table, and make sure that you remember this table here. All right.